Hello everyone, I am Anisha Mehta Jain, a student from CSC 3rd SEM 2nd year, Computer Science Department. I would like to present to you a small PPT on addressing mode and its types. So let us know what is meant by addressing mode. Addressing modes are basically the techniques that are being used in the computer architecture, or say it as an organization, that is used for accessing and manipulating the data of whatever is being available in the memory. So it is the critical role in how instructions and the data are being processed inside a given computer memory is being done by your addressing modes. So these are the ways of which the locations of the instructions or the operands that you pass into a memory are being specified. Moving on further with the types we have is the immediate addressing mode, direct addressing mode, indirect addressing mode, register, indexed addressing mode, relative addressing mode, base addressing mode. Let us look into each one of time with their advantages, disadvantages, and followed by the effective function, how are they being used in. Coming to the first one that we have is the immediate addressing mode. So immediate here, it stands wherein the operands, whatever you are going to pass as the instructions, it is seen to be given as explicitly itself, rather than in means it is directly being explicitly sent as the instructions. Going on to the usage, so it is being directly used to the access or the constants or the literal values. So that is the reason. So that is why it says it is being called as the immediate addressing mode. So whatever value you are going to pass in through for the operand, it is the access to the constants you are going to give, or say it as a literal values. It's not the variables that you are going to pass in. Coming to the advantages, since I told you it's immediate, so it's providing you a faster access to the data, that whatever is being stored in the memory, and it is whatever it is going to provide user friendly, so that it is faster access to the data for the instructions that is being stored in it. Coming to the limitations, it is not being suitable for the variables. As I told you, it is being available, or it is going to make you to access only the constants and literals, but not the variables, or say it as the dynamic data. So the immediate addressing mode fails at this point of time. Coming to the effective function or the addressing function that we have is that the immediate addressing mode is being represented by the operand to which a given value is given, isn't it? It's the constant, or say it as a literal value, not a variable. Coming further, next we have is the direct or the absolute addressing mode. So here what is happening here is the address of the operand is that is directly being supplied as the instruction into your memory. It is just the operand and its value, whatever it is, its address will be stored in it. The use it's commonly being used for accessing the data, that whatever is being stored in that specific memory location. That is the thing. Then coming to the advantages, as I told you, it is seem to be directly accessed. It is going to be, the addressing mode, it is going to access using the address of that operand that is being present. So it is providing you an efficiency in accessing that fixed memory address, rather than any other variable or operand for accessing to it. So it is just faster enough. Coming to the disadvantages is that you cannot, the dynamic accessing of the operands or the instruction is not possible, since I told you that it is being, making it possible for accessing the data that is being present to that exact location, not it's like indirect ways. So it is not possible for the dynamic accessing of the variables, or say it as operands, or the addresses of a given operand instruction. Coming to the addressing function of this one, it is like effective address of the addressing mode is being represented by the location of wherein the instruction or the operand is being present. So that is the addressing function of this. Coming on further, we have is the indirect addressing mode. Direct addressing mode is the directly the address of that operand instruction was being stored or being specified, wherein the location of it is being specified. In the indirect addressing mode, it is indirectly being, the name is itself the self-explanatory, which says that it's indirect, rather than mentioning the actual address or the actual location wherein the instructions or the operand is being stored. We have several addresses, which is going to lead you to the actual address of the operand. Coming to the use is that it is going to enable you to access the memory locations different memory locations. As I told you, it is an indirect means, so it is going to provide you a means of accessing the different memory allocation depending upon the specific memory addresses. Coming on for the further, the advantage or the benefit that you're going to get while using the direct addressing mode is that it is going to provide the flexibility and the dynamic memory access. So dynamic memory access, which the direct addressing mode did not provide to us, indirect addressing mode is providing, so that you can access various memory locations easily, so that it is flexible enough for accessing the variables or the not variable, the operands actually. Coming to the drawback that is there is, since I told you it is seem to be providing the indirect ways wherein you'll have access to different memory locations. Different memory locations means you'll have a series of locations in it, so which leads to the overhead of the actual addresses whatever is being present in it. So as a result, it is somewhere a complex thing that is going to happen. Coming to the addressing function, so here it is of two means. Either you can represent it by the means of the registers, whatever it is, wherein it is being stored, or say it as a location wherein it being stored. So it will include a series of locations wherein the operand instructions will be passed. Coming on to the further, that is your register addressing mode. Register, the term itself is going to tell that the operand instruction is there, no, it is being directly located in the register wherever it is being present. So the register is going to contain the operand instructions. So what is the use then? It is going to provide you a faster access. As we know, registers are readily available into your CPU memory. So it is being, it makes us feel easy that you have a faster access to your data. You can faster manipulate the data, whatever it is. So hence it is an advantage is that it is going to offer you the speed, efficiency in your data manipulation, retrieval as in the memory. Coming to the limitation, as I told you, registers. So registers are not huge in number that will be available to you in your computer. So it is seem to be limited by the number. If at all it's being present also, its size, its capacity seem to be reduced or say it as limited. Coming to the addressing function of this is being represented by the register. So Ri, if suppose for example, if we tell Ri is equal to 98, so this is how it's being used. So you will be assigned the location wherein or the operand value whatever is being stored to it. Coming on further, we have is indexed addressing mode. So index is something which we related to the array's position, or wherein to specifically we tell it that this is a value at which this will be present. It's basically the location we refer to. So it is correlates to the data structures of say it as the arrays as well. So this is going to involve an offset value that will be added to the base registered to the access data. Coming on further, wherein you're going to find its uses, that it is being useful in processing your arrays and data structures, as I told you, because array is also the kind of data type that is used for various operations wherein it uses primarily the index of a given values. That is the reason. So it finds its implementation in the array and other various data structures. Coming to the advantages, what are the advantages you find here is that you can easily access the elements of your data, of your instruction easily, since it is being mentioned by the means of your index. So using the index, you can directly access to those elements that are being present in your array data structures. Coming to the further one that we have is your relative addressing mode. The term relative is being referring to the current location or to the current program counter. Program counter is nothing but the set of instructions which will be executed. So this is being represented as the sum of the program counter whatever it is and the address of it whatever we have. So the operand's location is stated relative to the current location or the counter or the program counter. So wherein it is finding its usages, it is being finding its usage in the branch instructions and the procedure independent code wherever it's being generated. The advantages it is going to provide is that it is going to have a proper memory utilization, and also it is, as I told you, it is going to provide you a position independent code. So it is a advantageous to it, it is a beneficiary to us. Coming to the representation of the addressing function, as I told you, it is the sum of the program counter followed by the address of it. Moving on further, we have is the base addressing mode. Base addressing mode, base, so it's like sum of your base address whatever you have and the offset whatever will be there in that mode together makes up the base addressing mode. Coming to the applications, it is being useful in the situations wherein the data structures are there, right? They are being present at a specific location, specific memory address, whatever we have. So that is the reason, so that we know the base address to it, so that we find directly to that location itself. Coming to the benefits is that it is going to enhance the data access efficiency with the structured memory layouts to it. And the addressing function representation of the base addressing mode is the register of one value and register of another value together make up the base address of it, or say it as the operand's effective address. So wherein you, as I told you, the base address is required and the effective whatever address of the offset is being present, that is being required. Coming to the comparison of overall types, as I told you, that we have. So immediate, direct, indirect, register, index, relative, base, and the stack. So immediate, as I told you, it is like the faster access that will be provided to your constant. But the thing is that it is going to fail as it is only for the constant, not for the variables. So that is why it's a limited for us. Coming to the direct, as I told you, it's efficient enough so that you're going to go for the direct exact location of the operand instruction where it is being stored. So there are no chances of having the overhead of the locations or the memory addresses. But it seems to fail wherein you can't access the dynamic data that is being present in your memory. Next we have is the indirect. As I told you, it is flexible enough so that you are going to traverse through various memory locations, different memory locations, but this leads to your overheading in the fetching of the operand address, because you have to traverse through various memory locations to reach the actual address wherein your the operand is being stored. Coming to the next one is register. Register, as we tell, the moment it's your just to the speedy efficiency and whatever it is, it's in the memory address. Then coming to that is that it is seemed to be limited. Why? Because it's the number of registers that are being available to us and the size of the registers that are allocated to us. Coming to the index, index is something that is going to refer to the arrays data structures. So array data structure, something wherein you can easily access its members using the index value of it. That is the reason. The disadvantages is that the challenges that we face is that whenever the size of the array is small, it is turning out to be efficient enough, but since along with the size of the array being increased, it becomes a little tedious, it becomes a bit complex to retrieve the data. Coming to the relative, as I told you, it is being represented by the sum of the register, it is being represented as the sum of the program counter and the address of the operand. Then coming on to the next one, that as I told you, that is the base, which is a sum of a given operand value and the offset whatever it is. And disadvantages of it was that it was leading to the complex addressing calculations and all for the larger data structure. As I told you, it is going to add on to the one type of it, and the another one is the offset value as well. But the thing is that it is going to have a proper positioning independent code whatever is being required to it. Then we have is a stack structured method. So it is going to provide you a structure, a proper program flow and the data storage that will be managed properly to you. That is the reason. Coming to the limitation is that the potential stack space is that is a real task, because managing all of the memory into your program flow, whatever it is, the data storage and all, it can be done easily, but wherein the stack itself, it needs to be managed, but it is a little task wherein you find the management issues with it. That is the reason wherein you feel it's a kind of limited in its use. Moving on further, we have is the example for the how the different types of addressing nodes can be used. Coming on to the first one that we have is the given value to us is R1, that is a register which stores the value as 98, and the XR, which is the having a value of 3. And here we have is the representation of the relative address, which is the sum of your PC and the base address. Coming on next to that we have is the index mode, that is having the XR plus the base address whatever it is. So for the first that we have is the direct. immediate, indirect, relative, indexed, register, auto increment, auto decrement, and the one thing that we have is the address given to us is 100, and whatever the instruction is that you need to load to the AC, and here we have is the program counter. So let us now go on with the one by one for the effective function whatever we have. So direct is nothing but it is going directly to the address wherein the operand instruction is being passed. So if we have 100, so here can you see this is the address that is 100. So that is the thing, 100, at 100 what is being stored as an operand value, that is 105. So here we have as a content of your addressing mode as 105. Moving on to the next one that we have is the immediate addressing mode. As I told you, it is going to use the operands as explicitly in the instruction. So here it is not going to go any further. Address whatever it is having the value 100, it is 100 stored here as it is. Next we have is the indirect. So it is going to have a series of memory locations rather than the actual address wherein the operand will be saved. So if we refer to 100, it was referring to 105. Moving on to the 105 location, 105 location stores 500 as its value or as its content. So that is why we have here 500 and its effective address was this thing. Coming on to the relative, as I told you, the representation is actually as a sum of the program control and the address whatever we have given to us. So PC is nothing but the wherein the instruction, or say it as the wherein the execution of the next set of instructions is going to happen, that is refers to our program counter. So program counter is at your 52. So 100 plus 52 gives us your 152. At the location of 150 we have 70 as the content of it. So that is why here we have the 70. Coming to the indexed, indexed also is again being represented as the sum of XR and the address. So we have here, so the address was given to us as 100 and XR was given to us as 3. So 100 plus 3 giving us 103, wherein at the 103 location the content it has is the 65. So here is the 65. Registers, as I told you, register is the direct one. So whatever value is being stored, it is going to directly get located at that position, that is your 98. Auto increment, auto increment is nothing but the present whatever the address is there, for the next chance it is going to get incremented by location 1, and it is going to give you the, it is going to retrieve the content of that address which is being incremented after the one track. So that is, now first we had the address to be as 100. So when this 100 was incremented by 1, it gave us 101, and at the location 101 we have 35 as the content. So the 105 which was being present at the time of 100 as the address, 35 is being overwritten it. Then we have is the auto decrement. Auto decrement is the address of it, whatever is being present, it is going to get decreased by 1. So 100 address being decreased by 1 gives us 99. So at the location of 99 we have 800 as the content of it. So here this is the content of it we have. So this is the various types of addressing modes that we have given to us, so that each type is going to work differently, wherein as I told you, direct was directly referring to the address that was given to us, wherein indirect used a series of memory locations to us, and relative it was being represented by the sum of it, whereas the registered, it was just related to the register itself, no other address being used to it. So here this is the various ways in which we used it. And at last what I would like to tell is the advantages of having the addressing modes. It is going to make a faster access, easier access of your data, instructions of whatever is being stored in your memory, so that whenever the user asks in, it is readily available for them. So that is why this is the wherein we find the application of the addressing modes in our day-to-day life. in the computer architecture. Thank you.